So we also need to focus on our R value. So I don't know if you noticed the values that were given, they were decimal numbers. The value of your R will always be between either a -1 or a +1 and inclusive, and therefore they could be those values themselves. So between -1 and +1. If your slope is a positive slope, then it will be in the positives. It will be above 0. If you have a negative slope or a negative pattern, your R value will be negative. The values of either variable are converted to a different scale. The value of the R does not change, so just because you mess with your scales, your R value will not change, so you can't try and get a different answer. They are not affected by the choice of X or Y. So if you were to interchange your X and your Y axis, you still will have the same R value. Your equation would just change. R measures the strength of the linear relationship, right? So it's telling us how good of a job it does, how tight it is. It does not designate the measure designated to measure the strength of the relationship if it is not linear, like in the quadratic that we saw. And remember, it is very sensitive to outliers. That's why we talked about you might have to remove them and run it, especially if they're errored, you should remove them. Okay, so we're going to look at some information. We have 23 pairs of data. They come from different countries, and what these data represent are the chocolate consumption per capita of the country in kilograms, and then we're comparing that chocolate consumption to how many Nobel laureates they have from that country, and that number is per 10 million. So the chocolate is measured kilograms per capita. The Nobel number is measured per 10 million in the country, okay? And these represent countries, each one, okay? So we're going to go ahead and we would put this data into some type, there are two lists. We would put all of these numbers into some type of testing software, whether using your calculator or stat disk, and we would get it all in. We do have to make sure we check our requirements before we actually run the test. So the first one, is it a simple random sample? Well, that is definitely questionable. They just chose the 23, they just chose the countries, and they didn't actually go around and sample which countries were in and which ones were not. They didn't decide which years to use and which years not to use. So it is definitely questionable, and if this is a simple random sample. And so because of that, we shouldn't really run this data, but we're going to do it just to practice. You really should go back to the drawing board, figure out a way to simply random sample the data. So we already know we've kind of messed up on the first one. The second one, we need to look at a scatter plot to see if it is that straight line pattern. So here's our scatter plot. We can definitely see a straight line kind of going through here, and this point is about the same distance away as this point, so they would not be considered outliers since you have ones on both sides. So it definitely looks like it could be a straight line pattern. It definitely looks like there are no outliers. So for 2 and 3 requirements, we look like we're doing okay here and here, but this one is definitely questionable. So we're going to go ahead and we're going to run this test. So the claim is that there's a linear correlation relationship between chocolate consumption and the Nobel laureates. So how we write this when we're doing our hypothesis testing, our null and our alternative. So remember, we're talking, and we use the symbol rho when we're talking about correlation, when we're trying to learn about a population. So if rho is equal to 0, because our null is always equal to, what that means is that there is no correlation. You can kind of think about it as if your R value is 0. Remember, if an R value is 0, then it's kind of all over the place. It's that shotgun effect. There's definitely no pattern, and if there's no pattern, there's no correlation. Whereas the ones that were tight and actually had that linear pattern were not 0, they were closer to 1 or -1. So if your rho is not equal to 0, then there is definitely some type of correlation. And we're just going to do a generic there is a correlation and not what type of correlation. In the question, it told us to use an alpha of 0.05. So using our calculator or our stat disk, we're going to run the test. We're going to run a linear regression test. we come up with an R value of approximately 0.801. And to be more exact, it was 8006078, but we round to 3 places. We end up with a p-value, which shows a bunch of zeros, so we call that 0 plus. And so when we compare our p-value and our alpha level, our p-value is 0 plus, which means it's above 0. It's not impossible, but it is very small. Our alpha level was 0.05. Our p-value is definitely less than 0.05. Therefore, we're going to reject the null. So what we've decided is there is sufficient evidence to support the conclusion that for countries, there is a linear correlation between chocolate consumption and the numbers of Nobel laureates. So we can see we rejected the null, showing us that there is a correlation. So let me say it one more time. There is sufficient evidence to support the conclusion that for countries, because remember this was based on countries, there is a linear correlation between chocolate consumption and the number of Nobel laureates. Now the value of r squared is the proportion of the variation in y that is explained by the linear relationship between x and y. Now we just had an r value of 0.801. Now if we were to square that, and I actually would square the whole number, I wouldn't square the rounded number. So if we were to go square that, we get approximately, and I should be putting approximately here, 0.642. Now if I change that to a percentage, it would be 64.2%. So what this is saying that approximately 64% of the Nobel laureates winning their prize, right, is based on the chocolate consumption in the country. So how much of the y value or the y variable is being correlated with the x variable is 64% in this case, which means there's 36% of the Nobel laureates winning by country that is something else besides chocolate consumption. Now, of course, correlation does not imply causation, and this is a great example of that. It would be lack of definite common sense if we were to say that eating chocolate helps me win the Nobel Peace Prize or the Nobel Prize. We can probably think of lots of people who eat a lot of chocolate, me included. I love chocolate, and there's no way I'm going to win a Nobel Prize. One, I don't do anything that would cause me to win a Nobel Prize, which is probably a big consideration. So just eating the chocolate in itself is not enough to win the Nobel Prize. So things we have to be careful of are common errors, assuming that the correlation implies causality, definitely not going to be true all the time. Making sure that we are using individual data, not data averages. Making sure that when you're focused on a regression, that the R value only works with linear regressions or linear relationships, not nonlinear relationships. Now, we did where we just looked to see if there was a correlation, and we didn't focus on one or the other. Now, you can focus on if there is a negative correlation or if there is a positive correlation, and so a negative correlation would show a negative slope, a positive correlation would show a positive slope, and so when you go to write those, you just use the inequality signs. So here, rho is less than 0, and for a positive, rho would be greater than 0. And try really hard to write rows. Those look a little bit too much like p's. Okay, go ahead and try this assignment. If you have any questions, let me know, and I'll get back to you with lesson 10 too.